Hello everyone, this is Group 5 and our topic for the project is double wishbone suspension system of a car.
A car consists of various systems that come into play to provide a great riding experience. One such essential component is the suspension system, which is responsible for enhancing the level of comfort and improving the handling of the car. A double wishbone suspension system is special because it allows each wheel to act independently of the other. So we finally decided to go with the double wishbone suspension system because this would help us understand the complexity in the design and working of the suspension system. Additionally, the suspension system had sufficient components and it was complex enough to ensure that this would enhance our modeling skills in the Autodesk Inventor through practice of various modeling techniques and functionalities and understanding of assembly constraints. Coming to the process, the first step was to understand the suspension system so as to break it down into individual components. After that, all the components were divided among the team members so that each part could be analyzed and the preliminary sketches were drawn. After that, each of the component was dimensioned properly to ensure proper assembly. This was followed by modeling of all the individual parts on the Autodesk Inventor and finally assembling them to get the double wishbone suspension system.
So now coming on to the challenges that we faced. There were several challenges which we faced while modeling this suspension system. The first, as we know, the suspension system is a very complex and it has many components. And to study and understand the functioning of that components and how they work and how we will assemble it and how we will give dimension, it was a bit difficult to collect the data and see many things. So we had done many research, had googled the some parts and seen YouTube videos that which parts are made and are joined in the suspension system and used in suspension system. And the other, I would say, the other major problem that we faced was dimensioning. How to dimension the parts, how we will constrain it, and how it will fix together. And the dimensioning of one part will affect the other part. It was a major problem for our team, but we overcome it very well, and everybody worked together with communicating each other that what dimensions we need to make, and we decided that a particular scale that we decided to make. And another thing I would say that is we have while making this project, we have explored many more features which are required to design different parts which we would have not designed making simple things.
Okay, so now let's look at the individual components of the suspension system. We will also look at how they affect the overall assembly of the suspension system and other components affected by the component. Okay, so now let's look at the part front upper arm mount. It is responsible for maintaining suspension, geometry, and distributing forces within the suspension system. It provides a secure mounting point for the upper control, and it is also a potential shock absorber. Its proper functioning is essential for its stability and overall performance of the vehicle suspension system. Okay, so now let's look at the front side plate. The front side plate is a connection point for the shock absorber and it also helps distribute the forces within the suspension system. It also contributes to the overall stability and performance of the vehicle.
Let's analyze the working of the shock absorber. As you can see, the shock absorber is connected to the side plate. This is done so as to ensure that the shock absorber is securely fixed at its location and has a stable point for its operation. When the wheel encounters an uneven surface, it moves in the vertical direction, as a result of which the front lower arm acts as a pivot. As a result of this, the shock absorber compresses. This compression is facilitated by the compression of the suspension spring, which applies a force on the shock absorber. The shock absorber then tries to resist this compression, as a result of which it absorbs the incoming kinetic energy, which is successfully dampened. Because of this whole process, the ride becomes much more smoother. Let's analyze the shock absorber. The shock absorber primarily consists of four parts. The first part is the shock body. So the shock body serves as the main housing for the shock absorber components. It contains the hydraulic fluid and piston assembly that dampens the movement of the suspension spring. This next important component is the suspension spring. The suspension spring supports the weight of the vehicle and helps absorb shocks and vibrations from the road surface. It provides the primary force required to compress and extend the shock absorber. Then comes the shock strut. The shock strut, as the suspension spring moves, the piston inside the shock strut moves through the hydraulic fluid, creating resistance to the spring's movement. This action converts the kinetic energy from the bouncing suspension into heat energy, effectively dampening the oscillations and providing a smoother ride. Finally, the shock spring adjustment nut is responsible for adjusting the preload on the suspension spring. By turning the nut, you can increase or decrease the tension on the spring, which affects the stiffness and overall performance of the shock absorber.
So our next component is front shock brace. So this is the location of front shock brace in the double wishbone suspension system. So basically it connects the left and right shock absorbers, and it also connects them to the front upper mount. So what's the function of front shock brace? Basically, it helps reduce flex and torsion in the front suspension system. Thus, by reducing the chassis flex, it allows the suspension components such as shocks and struts to work more effectively and efficiently. So this modeled front shock brace leads to improved traction, reduced body roll, and enhanced responsiveness during cornering and other maneuvers in our suspension system. Now, coming to the next component, the front lower arm brace. So this shaded component, it is the front lower arm brace. So here it connects the left and right front lower arm, which are also connected to the left and right side plate respectively. So coming to its role is to provide additional reinforcement and stability to the front lower control arms. So this front lower arm brace provides four benefits in our suspension system. These are increased structural integrity, enhanced stability and handling, improved traction and grip, and reduced noise and vibration.
Hello everyone. Now let us discuss about the two major components in the vehicle car suspension, which are with the control arms. They are the front upper arm and the front lower arm. As you can see, the golden one is front upper arm. The brown one is the front lower arm. The two front upper arms are connected to each other through front upper mount, and the lower arms are connected to the front side plate. Now the front upper arms and lower arms play a crucial role in maintaining the means in distributing the overall force, vertical force, which is faced by the car. As you so the front upper arm and lower arm work together to control the wheel movement and maintain stability. So when vehicle encounters bumps and road irregularities, the front lower arm, lower arm absorbs the vertical forces, and the front upper arm helps to maintain the proper wheel alignment and the suspension geometry. These two arms play crucial role in distributing the forces and loads experienced by suspension system during acceleration, braking, and cornering, etc. These play a vital role. By transferring these forces between the wheel hub assembly and the vehicle chassis, they contribute to stability, traction, and control. Furthermore, the front lower arm and upper arm interact with other suspension components such as shock absorbers, sway bars, and steering linkages, so that allowing them to work in harmony to provide a comfortable ride, responsive handling, and optimal performance. So they are some of the most important components in the car suspension overall.
So coming to the next part, we have wheel assembly, and it consists of front hub carrier, wheel, tire, front axle, rear hub bearing, front hub bearing. So how these parts are connected to the wheel assembly? So here we have tire, wheel, front hub carrier, front axle, front hub bearing, and at the back side we have rear hub bearing. So what is the role of front hub carrier? It helps in the rotation of the wheel while maintaining the stability, and it also helps to connect with the suspension system. Wheel, it supports the weight of vehicle and allows it to move, and tires are mounted on them. Front axle, it transmits the energy from the engine to the wheels, which helps the vehicle to move or turn. And there is a lot of friction and heat generated when wheels are rotating. And rear hub bearing, front hub bearing helps in reducing the friction and heat and making them smooth.
After assembling all the components discussed earlier, we have modeled this double wishbone suspension system. So here what it looks like. Finally, I would like to thank Professor Jaiprakash and our TA for helping us in this challenging and wonderful project successfully. Thank you.